we want to evaluate the definite integral. To determine the antiderivative, we'll be applying the integration formula given here, where the integral of e to the u integrated with respect to u is equal to e to the u plus c. Notice in our case, because the exponent is not just x, when integrating with respect to x, we'll have to perform u substitution, or a change of variables. So we'll let u be equal to the exponent of 0.05x, and therefore differential u is equal to the derivative of 0.05x with respect to x times dx, which would be 0.05 times dx. Notice how we don't have 0.05 dx as part of our integral. We just have a dx here. Let's solve this for dx by dividing both sides by 0.05. Simplifying, we have 1 divided by 0.05 du equals dx. Now we'll write the integral in terms of u. Let's go ahead and factor out the 260. So we'd have 260 times the integral of e raised to the power of u, since u equals 0.05x. That leaves us with dx, and we now know dx is equal to 1 over 0.05 times du. So we'll factor out the fraction, and we have our differential u. We will not include the limits of integration here because the limits of integration given here are for x, not u. So let's go ahead and rewrite this as 260 divided by 0.05. And again, the integral of e to the u with respect to u is e to the u plus c. But because we have a definite integral, we'll leave off the plus c, and e to the u would actually be e to the 0.05x. And now because we have the antiderivative in terms of x, we'll again include the limits of integration, which are from 0 to 5. So this is going to be equal to 260 divided by 0.05 times, when x is 5, we have e to the 0.05 times 5, minus, when x is 0, we have 0.05 times 0. So simplifying, we have 260 divided by 0.05 times, this would be e to the 0.25 minus e to the 0, which is equal to 1. So this is the exact value of our definite integral. Let's also get our decimal approximation. So we have 260 divided by 0.05 times the quantity e. If we press second natural log, it brings up e raised to the power of 0.25, right arrow, and then minus 1. Close parenthesis, enter. To 4 decimal places, this would be approximately 1,476.9322. So here we have the exact value and the decimal approximation for our definite integral. Remember, in our homework system, if we enter the exact value and click the preview button, it will show the decimal approximation. I hope you found this helpful.